going to find the three cube roots of positive 1 by DeMoivre's theorem. Now, there's a way, and I've seen it quite a few times, so my mind goes to just the xy coordinate, or actually not the xy coordinate. It goes to the real and the imaginary plane. Imaginary numbers are on the y-axis, and the real numbers are on the x-axis. But it's really, this is, if you've seen, complex numbers can be given as a plus bi. In this way is the real. This is the real part. The real, that's that fancy r. And this is the imaginary part. Imaginary part. So what I'm usually thinking, or what I'm envisioning, is a, let me get a better color for that. I'm envisioning a circle, and this circle isn't too bad. We're trying to find the roots of 1. So this is my point 1, 0. It's out on the real axis. There is no imaginary part of just positive 1. As a complex number, it would be 1 plus 0i. So this is totally a real number, and we're trying to find the cube roots of it. Like I said, in looking at this, I know that this rotation, it's a 0-degree rotation, or you can also think of it as going around once, and it's a 2 pi or 360-degree rotation. Well, if I would take that 360 degrees and I would divide it into 3 equal pieces, I know that one piece would be there and the second piece would be there. 360 divided by 3 is 120 degrees. So this rotation, if you look at, let's use that color. This rotation is 120 degrees. And the other rotation, if I go around to the second one, this is going to be 240 degrees. And of course, going one time around and landing right on that one is 360 degrees. I'm going to find, it's going to be this point and this point, and this point are the 3 roots, the 3 cube roots of 1 by DeMoivre's theorem. Let's do it that way. Let me just go back to this. We're on the unit circle. We're on the unit circle of 1, and if you have a 120-degree rotation, the coordinates to this point right up here, coordinates to that point, if I go through a 120-degree rotation that's got a 60-degree reference angle, the x value being the cosine of 120 degrees, and the y is the sine of 120 degrees. The cosine of 120 degrees is, what is that? That is the cosine, the negative cosine is 60. Cosine of 60 degrees is, that's going to be negative 1/2. Cosine of 60 is 1/2, but I'm in the second quadrant. Let me make this a little bit clearer. This is going to be negative 1/2. And then the sine of 60 degrees. And it's in the second quadrant, so the sign is positive still. It's going to be the square root of 3 over 2. Down here, the other root is going to be, what is it? This thing is going to be still negative 1/2, and it's going to be negative square root of 3 over 2. That's just how I start that. All right, that's what my mind is thinking, but I've seen these a few times. If you haven't seen these, then let's just go about it how DeMoivre wants you to do this. We got x cubed equals 1. So I want to find the cube roots of that 1. I want to find out what x is equal to. So I take the cube root of this side, and I take the cube root. Can I squeeze a cube root in there? Let's see, squeezing a cube root in there equals, this was 1, and I'll take the cube root of both sides. So the cube root of x cubed is x, and this is the cube root of 1. Now we know the real root of this is going to be 1. everybody says, okay, even Algebra 2 kids and maybe Algebra 1 kids can say, what number times itself 3 times gives you 1? Well, that's going to be 1. But we should be expecting, from the original equation, we should be expecting to have 3 roots, which we will. We should expect 3. We're going to get 3. Okay, so one of the x's is equal to 1, but the other two, DeMoivre's says that, hey, to find this, he uses this formula. This is the nth root of r, where r is the radius of the circle, and then we're going to go cosine of theta plus 2 pi k over n plus I sine theta plus 2 pi k over n. Now, let's think about this. This is where n is equal to the number of roots that we're trying to find. We're trying to find 3 right here. And k is equal to 0, 1, 2, and then it goes dot, 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 and then we go n minus 1 at the end. Well, our limit is actually going to be at 2 because n is this 3. 3 minus 1 is 2. So we're just going to have this 0, 1, 2 that we're going to have to use this formula for. We're looking for 3 roots. Let's see. The r, once again, the r is the radius of this circle. So the radius is 1. Now, if we just plug in what we know, okay, we're taking the cube root of 1 times the cosine. The cosine, when we start out this circle, we are, oh, erased too much there. Let's try and do this. Let's see. Erase some of this. I want to erase a little bit of this. I don't want to erase it all. So I'll erase that. We're trying to find the cube root of 1. This is a 0 degree. Our theta is 0 degrees. Okay, so theta is 0 at when we're at 1, 0. So this is going to be 0 plus our first k. This is going to be for k is equal to 0. Yeah, we're putting in 0, 1, 2 for k. So this is going to be 2 pi times 0 over the number of roots. Oh, that's going to be a 3. Plus I sine 0 plus 2 pi times 0 over 3. And we work through this and we say this is going to be equal to the cube root of 1. That's 1. Cosine 0 plus 2 pi times 0. This whole thing on the top is 0, so it's the cosine of 0 plus the I sine of 0 plus 2 pi times 0 is 0 over 3. That's 0. Okay, so this is going to be 1 times cosine of 0 is 1. So this whole thing is 1. And I times the sine of 0 is 0, so I times that 0 is 0. So there's going to be 1 plus 0. Hey, the first root is that real root. Oh, this I could have just put times 1. 1 times 1 is 1. That's the first root. That's that real root. That's the one we found already up here. Anyways, okay, so that's the first root. Let's do this for k is equal to 2. Oh, k is equal to 1. Let me go in those kind of steps. This is the cube root of 1. And this cube root of 1 out front is just, you're finding the real root of that. I don't want to make it too complicated. Cosine of 0 degrees or 0 radians plus 2 pi times 1 over 3 plus I sine 0 plus 2 pi times 1 over 3. And 0 plus 2 pi times 1 divided by 3. That's just going to be, this is equal to the cube root of 1 times the cosine of 2 pi over 3, 2 pi over 3 plus I sine 2 pi over 3. If you're more comfortable working in degrees, this thing and as well as this thing, they'll both be the same thing. Pi is like 180 degrees divided by 3 is 60 times 2. Hey, that's that 120 I was talking about before. This is the cosine of 120 degrees plus I sine 120 degrees. That's in the parentheses. This cube root of 1 is just 1. This is 1 times this will just be whatever's in the parentheses. Cosine of 120, what did we say that was before? That is negative 1/2. And then plus I times the sine of 120. The sine of 120 is the square root of 3 over 2. That is our second root. So we've got 1. This was the real root of it. And then the first imaginary one that we see is there. The other one for k is equal to 2. K is equal to 2. I do the cube root of 1 times the cosine of 0 plus 2 pi times k, which is 2 now. K is 2. And this is over 3 plus I sine 0 plus 2, or plus, 2 pi times 2 over 3. This is going to be 1 times cosine 0 plus 2 pi times 2 over 3. This is going to be cosine of 4 pi over 3 plus I sine 4 pi over 3. Once again, if you're more used to working in degrees, you can think of this 2 pi as 360. 360 times 2 is 720. 720 divided by 3. This is going to be 1 times the cosine of 240 degrees plus I sine 240 degrees. Let's see, 1 times, if I distribute this 1, it's just going to be what's inside there. Cosine of 240, we said before, was negative 1/2. Plus I sine 240, this is going to be plus, it's I times negative square root of 3 over 2. So this can be thought of, if I take this positive and multiply it by the negative, positive I times the negative square root of 3 over 2, this other root is negative 1/2 minus square root of 3 over 2. Okay, so there are our 3 roots. Anyways, you ever wonder why those work? Let's see how those relate. If I go back up, that was what I was getting before, right up here. When I said, hey, having done this a while, I said if I go a whole 360-degree rotation, I divide that by 3, I'm at 120 at this one, I'm at 240 at this one, and I'm at 360 at the other one. Okay, so why does this work? Or if you've ever verified why it works. Let's try cubing those things. If we try cubing all these guys, let me see if I can get another page here. And I'm moving everything around. Let's see. I don't want to move that around too much. Let's do this. Let's go like that. And I'm going to go back to where? Go here. I'm going to get us another page. Other page to work on. There we go. Seeing I'm at 14 minutes, I'm going to stop this right now. I'm going to start another one.